So, can everybody hear me in the back too? Perfect. So, hello everybody. I'm going to talk a little bit about flow-based programming. In short, I'm Henry. I'm originally from Finland, doing webby stuff, web development for over 20 years. Quite a long time with PHP, and then I entered the happy world of JavaScript, and that brings me here. Let's talk a little bit about control flow in software. This is more my PHP background again. Okay. So, like the traditional way of doing I/O is the call return pattern, where you call some function. Let's say you read from a database, you talk to a web service or whatever, and your whole program execution stops until you get a response back. And the problem there is you might actually, on a good day, have more than 2 people using your web service at the same time. So then you need more servers, and you know how that is. Luckily, with Node.js, we have the continuation passing style that comes from functional programming, Lispy things originally, where, yeah, you call the function, then you give it a continuation, so another function to call when things are done. You all know this, so we can kind of go fast. And the problem with continuation passing style is that you get the Christmas tree, right? This is how my first Node.js project looked like. Nowadays we have promises, we have all these other fancy things that help there a little bit, but especially when the things get complicated, it would be very nice to have a map.
Like Berlin.
Okay. So that's where kind of I come in. 6 years ago, I was doing some work in US. I had to do some travel on the West Coast, and that gave me a lot of time. I was doing road trips, and that gave me a lot of time to think about how I would like to do software better, with better tools, read a lot of papers, etc. Yeah, that's California one, somewhere between San Francisco and Portland. Yeah. So anyway, that one of the papers I ran into was about flow-based programming, and that really clicked for me. I read a little bit more about it. Flow-based programming was invented or discovered, as he says, by J. Paul Morrison in late 60s at IBM. So what we're talking about is really cutting-edge stuff here. When he retired, he had time to write a book about it. And yeah, this slide actually explains everything. This is actually, I'm going to show this more in Node.js context, but this is what we're talking about. Punch cards. Exciting, right? So what flow-based programming is, like how to understand it is, at IBM, they had these unit record machines, these things that would do things with punch cards. Like this wonderful, I think, collator here. Basically, the idea is that you have trays where you put punch cards, maybe you put other punch cards in another tray, then the machine processes them. Maybe it sorts the punch cards, maybe it puts them to different places, or maybe it creates new punch cards based on that input. And that's basically a function, right? And then how you actually built your software, how you built the system was by drawing these wonderful flowcharts here. Because the control flow of your software was people in white lab coats taking punch cards from this tray, looking at the flowchart saying, okay, if they come to this tray, then we need to put them to this tray. And yeah, that's what we're doing in NoFlo, except we do it with computers. These concepts might sound familiar from other places. This is Alan Kay talking about how he thought about object-oriented programming originally, how it would be this message passing between things. Then somehow we got Java. Another place where very similar era again, like object-oriented programming, flow-based programming, Unix, they are all kind of from around the same times. So with Unix, the idea, I'm not going to read this to you, but you probably all know. The idea is these little tools that do one thing and then being able to string them together to do stuff. I mean, how many of you have used the pipe character in a command line? I would imagine pretty much everybody. Almost. Very good. So you have actually done flow-based programming already, just not with Node.js. Yeah, so that's flow-based programming in 1D. What we felt is, humans have very good spatial understanding. So could we do these things in 2D? I mean, go from go from this thing where, yeah, you can see what's there, but it's a little tricky, to this thing where you can actually see what data is flowing through all these connections. And that's what we did. What people ask me usually is like, hasn't this been tried before? People have done these flow-based or visual programming tools before, right? And yes, they have. Actually, some of them have been very successful, even though most programmers don't know about it. There's things like LabVIEW, which is very common in engineering simulation area. There's things like Unreal Blueprints, which is used for game development. A lot of the visual effects industry is using tools that look very much like ours. It's just that nobody's really done this for general purpose programming. And that's what we try to do with NoFlo.
Sorry, one question.
Yes.
Like LabVIEW is a general programming language. So basically, in theory, it's just like, I mean, yeah, it's string complete, blah, 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 but it's also like, it has also sets. So actually, you're wrong. Like, I mean, it has been done before.
Yeah.
And like the lead technicians and whoever uses LabVIEW, they're doing general software with it. So.
Yeah, okay, you could argue. So the argument there was that, yeah, LabVIEW is Turing complete. This is correct. You can do general purpose programming, but that's not why people buy it, right? It's very expensive software package. You build it if you need to design a wind turbine. You don't build it because you want to build a website. So that's one thing. So anyway, that's where NoFlo comes into the picture. So a little bit about the interface. So NoFlo is a JavaScript library, runs on Node.js. You can also build it with Webpack or whatever for browser. There's a little bit of boilerplate for building a component. Basically, you instantiate the component interface, you add some ports, then you provide your processing function. So this is when I get input data, call me kind of thing. There you can do stuff, then you send output, and that's it. It's a little bit of code, but luckily, in most cases, you don't really have to do it because there's actually tons of NoFlo components out there on NPM. We've written a lot of them. Other people that we don't know who they are have written a lot of NoFlo components. So like for a lot of programming tasks you need to do, like usually you can kind of build your system by just grabbing things from the existing components, putting it together, and maybe writing one or two custom components for something that nobody else had to do before. So how do you define a flow? Of course, there's a JavaScript API as well. Then there's this lovely domain-specific language that IBM developed in the 80s, where you can say, okay, send value 80 to the port of the server. So tell the server to start in port 80, then send the server to that thing, and so on and so forth. This is something that we occasionally still do because sometimes you just want to work with your text editor. But really what you want to do is this, right? So this graph, and this graph are the same thing. You can write it in one and convert it to the other. And this is just a visualization. So here you can see we have a web server. It has a port thing there where we send 80. Then we send the server to a piece of middleware, which we also configure with the 1 megabyte limit. And then we send it to a router and so forth. So with this, you can easily see what's there, what's done. Like you can see, okay, we connected here we have created a resource called image. We have connected the create port and the destroy port. So this means we can create images and we can delete them, but we haven't connected, for instance, the index or update. So those are the only operations currently this endpoint supports. But you can at least see like, okay, there's a couple of gaps we might want to fill. So this is one part of like, when you see the software laid out like this, you can much more easily understand what talks to what and what might still be missing from the implementation. So to be able to do this kind of visual programming, 4 years ago, we ran a Kickstarter to build a visual programming tool that would be open source called NoFlo Development Environment. And yeah, it went pretty well. We were at that time, like I think the 5th largest software Kickstarter. Any of you actually happen to back it? No. every time I've asked this at another conference, I've always at least had one hand up. But anyway, yeah. So we built this, we released it, it's out there, and then we changed the name. I'll come to the reasons in a bit. But nowadays, the tool that we funded with the Kickstarter and released is called FlowHub. And what can you do with it? Well, first of all, you can see your software laid out. This one is not a Node.js program. Sorry about that. This is a browser-side JavaScript program. So in this case, we are communicating with the little iframe here running NoFlo. This is the graph. And what it does is it starts the webcam on your machine, and then you have some buttons here and sliders to tweak with some GL shader-based video filters, so you can like play with different video filtering things live while you make silly faces at the camera. And then, of course, in the tool you can write components because, yeah, sometimes the components you need don't exist, and it's nice to be able to do it right there in the same tool. So in this case, we have a NoFlo component written in CoffeeScript that is a Markdown parser. And then, of course, you can also write tests. So in the same tool, these could be Mocha or whatever you like to use. In this case, we are using FBP Spec, which is a test runner specifically for testing flow-based systems. And yeah, if you change this, it will run the tests and you will immediately see if things are green or red or whatever. But as I said about writing components, there's another way to produce a new component, and that's where the composition part comes in. So once you have drawn a graph, you can actually select a bunch of the nodes there, and then you just, from the context menus, you select graph, it becomes a subgraph, and the subgraph is essentially a component of its own. So each of these boxes you see, they can either be code or another graph. So this way you can easily package complex functionality down to different pieces and all that. And then, yeah, in the tool you can also synchronize with GitHub, so you can commit, push, pull straight from the UI. So what can you build with it? You can build a lot of stuff. How many of you have been to Seabase since we're in the Berlin meetup now? Very good. Have you seen the table? Yeah. So this table has a Raspberry Pi inside running NoFlo. What it does is it talks to the Ingress API. Ingress is a location-based game that was done by the same people who did Pokemon Go later. And it visualizes the Ingress game state around Seabase. So this is basically a visual artifact, like a smart piece of bar furniture. And yeah, we built this, I think, 3 or 4 years ago, and it's been running since. So that's a nice thing. And you can actually connect FlowHub to the thing. You can see the graph, you can see the data packets going on, so you can inspect a piece of furniture in your IDE while it's running. Another example, this is from the browser land. This is actually the NoFlo UI, so FlowHub is actually built in NoFlo as well. And this is the Redux middleware chain of the UI itself. But so the reason why we call it FlowHub was that when we started working on it, we wanted to actually support both Node.js and browser. Supporting both of them meant we needed some sort of a protocol for the UI to talk to the runtime, and we ended up defining that. And then turns out other people were interested in having UI as well. They had other flow-based environments, other ideas for data flow that they wanted to do. And so we end up standardizing the protocol, and now there's other tools. There's our IDE, there's testing tools, there's debugging tools that can then use the same thing. And this means with the same UI, you can actually develop Node.js applications, but you could also develop things for Python or Go or whatever. And a couple of interesting ones. How many of you have used GIMP? A few, good. So did you know that GIMP is actually a flow-based image processing engine internally? Inside GIMP, there's a tool called Gaggle, which is flow-based. And turns out you can expose that image processing engine into our IDE. And then you can use this visual programming tool to create new filters for GIMP. So that was one of those things we didn't really expect when we built this. And you can actually write news operations in C if you really want to. And another interesting one was microflow. So this is running on microcontrollers, so really cheap and constrained hardware, like Arduinos and those kinds of things. And this was built by a friend of mine who had a problem. He had a fridge that didn't work, and cold beer is kind of important. So instead of throwing the fridge away and buying a new one, being an electrical engineer, he decided to fix it. And so he built a new thermostat for the fridge. He built a programming tool for that, and then wired it up with Arduino and programmed his fridge in this visual programming tool. As an end result, what he has is a internet-connected fridge built in 1970s in Eastern Germany. So yeah, there's a bunch of these runtimes nowadays available. But now to Node.js land. So just a little bit, how does this work? So as I said, NoFlo itself is just a library. You can use it as it is inside existing applications. Or then we also have this runner called NoFlo Node.js, which actually starts a WebSocket server that our IDE can talk to. And so you can just install that into your project and then run it like shown here. And then in FlowHub, you can say, okay, my runtime is in this address, and then you can actually program it live. And yeah, in the talk description, there was some promises of Express, right? So we should go to that. So here, this one you saw already. This is an Express server. And why I put it here again was just to talk about like the two different ways to use NoFlo in your existing project. So one is you go all the way in. That's what you see here. So actually, your Express server is a node in NoFlo. Your middlewares are nodes in NoFlo. Your routers are nodes in NoFlo, and so forth. And this is really nice if you're starting a new project, because then you can see your whole code base in a single graph, and you can see the data flowing through and all these things. But that's not the only way. The other way is to use the embedding API. So the NoFlo as callback, the thing you see here. So with this, you can use NoFlo as just a library. So you can say, okay, here's my graph, make it a function. Then you get the function that accepts some inputs and a callback, just like any Node.js function would. And you can run it inside your existing application. So this is nice if you have some complex business logic that you want to do in NoFlo. Like, for instance, we've done a lot of payment-related stuff there, but you still have an existing code base where you just want to plug it in. And this way, yeah, you can draw your graph in FlowHub, export it to JSON, add it as a dependency of your project, and then you just make a function out of it and call it. So, live programming. Do we have time for that? Yes, we do. Very good. All right, let's see if my code is visible. Well, the good thing is you can zoom here. So again, apologies, I'm gonna start with a browser side graph. So in this case, we are communicating again with an iframe here. You can click the button and it generates a new random colored canvas. But we can change the behavior. So this is one nice thing. When in NoFlo, the components are code, but then the graph is actually just connections of event emitters with each other. That means you can actually go and change them at runtime. So we can modify this piece of software without stopping. So with this, you can get rid of this classical, edit, recompile, run again thing that we all have spent most of our life in. So let's add some nodes. We need that, we need that. So what I'm planning to do here is I'm going to repurpose the button. So what it does now is, as I said, it just generates a new pattern. What I would like to do is actually make the patterns run constantly, and then change or start or stop when you click the button. So what we do first is we remove the connection from the click to that one. We wire that in instead. Wire that. Then we wire the click to this component. This component is nice. It just has multiple output connections, and it just sends packets it receives, like to the first, to the second, to the third, to the first, to the second, to the third, etc. So in this case, we can make it toggle our animation. So we can go start, and we can go to stop. And then we just provide an interval, let's say 500 milliseconds. Sound good? So now I click the button and it animates. I click the button again, it stops. And you can actually go and you can see the packets that have gone through these different wires here. Nice. Okay, Node.js. So here I actually need to start our little server. This is going to be very small font, but luckily you don't have to read it. So I'm going to just start our runtime and connect to it. Okay, now I get the list of components. Very good. I get more components. Very good. Express. So we need a web server, right? And then we probably want a router. So let's say resource. And what I want to do here is I want to do an RSS reader, because RSS readers are nice and Google doesn't provide one anymore. So what do we're going to need a couple of middleware, right? So we have our resource, we have our server, but that's not quite enough. Like, first of all, we want to be able to subscribe to feeds. So for that, we probably want a body parser, right? So that we actually get nice JSON data out of the thing. So we send the server to our middleware, and then after that, we go to the router. So with that, we get our requests parsed. And then we want to be able to subscribe. So for that, first of all, I don't want garbage data. So I want to validate a JSON schema. So schema/feed JSON, for instance. So in this case, we have a JSON schema saying, okay, feeds should have a URL. Very fancy, I know. We wire that to create. So now we have a route-specific middleware here. This could be also authorization, authentication, whatever other things. And then I also created a component for this. Just give it the information where our database is. And now we can wire the request there. So in this one, in the validator, this component I wrote earlier today. and that one just runs a JSON schema validation. And if the payload doesn't validate, it gives a 422, and otherwise it passes the request along. But it also sends the failure to error, so if you want to do logging or whatever, you can also connect to that one. And then let me just add a couple more of these guys that I wrote earlier. So there's one for index. So this one just queries the same database. And then we have a, yeah, okay, this is a good start. Okay. Then we want to do a route for actually showing an individual feed. So this is where we actually do some RSS handling. So again, we want the database, and then we have the request. And now this component has two outports. So there's the request, and then there's the URL. And the URL is basically when you say, okay, give me the contents of the feed number 1. We get the URL there. And we can actually go and fetch the contents. So with that, and then that component. And now with the RSS fetch feed component here, we can have two results. So one is error, like let's say the server we are trying to get the feed from is down, or your internet is too slow. So we want to handle the error there. And then from the outport, we get the actual feed contents. That should be a web app, right? Am I missing anything?
Does out send the result to the browser?
Yeah.
Send feedback? No, on the right, on send feedback.
Yes, exactly. So if we open that, it just does a REST JSON items. So yeah, that's basically it. And yeah, then we want to start the server, and for that we need the port, let's say 5000. That's what people usually use in Express examples. And now we can actually start the server. And now, if we look at these things, we should see some output as soon as we make a request. Okay, let's see. Yes, so there was a request. It went through from the create port to the validator, and since it passed validation, it also went from there to the create feed. So now we should have one feed there. So what we can do is, oh man, I should probably zoom this one in a little bit. So now if we fetch the list, we get that there's one feed available. So that was again, that was this request here that you see. You can visualize them in a nicer way, but, and then if we do this one, yes. So here you can see we requested the RSS feed, and luckily the internet gods were with us today, and we actually got the stuff here. So, questions?
How much code did you generate now altogether?
It doesn't generate any code. No, NoFlo doesn't. So the question was how much code was generated. NoFlo doesn't generate any code. The graph is just a JSON file that tells NoFlo what event emitter to connect to what event receiver, and that's it. The components are code, and the only thing that NoFlo does when it starts up is just do some port on this and that, port on that and that.
Okay, so you have your own server. I mean, where it is hosted? So it is inside your, I mean, flowhub.io. I mean,
no. FlowHub is just a web app. It runs in your browser. You talk to our server, you get the web app. Everything after that is.
So I will download the app. I mean, how I will get my own app after designing in the browser?
Yeah. So your app is just a JSON file.
Yeah.
You can put it on GitHub. You can download it to your own machine. You can run it wherever you want. So there's no server component to this per se.
What's the client front end framework you use? Angular or React for the front end?
Polymer.
Polymer.
Yeah. Okay. Next question. Yes.
So I think this is a Node.js meetup, so you were probably focusing this somewhat on Node, but actually, isn't this completely unrelated to Node? This whole thing was now really an Express app, how we know it from Node, and why bring all this kind of luggage into this new world? Why not just say, okay, scrap it, we're also reinventing this?
Okay, so the question was why to use legacy technologies like Node.js. Okay, because it gets me to talk to these wonderful meetups that give me beer. That's one part of it. But I mean, I don't believe in reinventing the wheel. I think JavaScript has certain wonderful attributes to it, and one of it is that it runs everywhere. You can do Node.js is not only targeting HTTP, like PHP mostly used to be. You can do anything. We've done like hardware projects, like program robots with this stuff. So I can do a lot of things with Node.js. And the second thing is, turns out you can also make this run in the browser, and at that stage, I can use the same NoFlo, the same tools to program something that runs on an iPhone or runs on your smart fridge. So that's kind of nice. But yeah, I mean, I'm a JavaScript developer, so of course I targeted JavaScript. There's other people who have built compatible tools for other environments like Python, Go, etc. So, and the nice thing is because they all use the same concepts, they all speak the same protocol. You can use all these same tools. You can see the live data going through, etc. with all these things. Okay. Yes.
How do you envision this working with more complex systems?
Yes, glad you asked. We just had a talk about microservices, so I should have actually brought this up earlier. So one thing, like NoFlo itself only focuses on a single Node.js instance. So this graph that you see is something that runs on a single machine. However, then we have another tool called MessageFlow, which makes it easy to take these nodes and run them on different machines connected with message queues. So that's what we do with bigger systems usually. And the nice thing is, like, you can start with a monolith, like our Express app that we just built. This is a monolith, right? And there are clear bottlenecks, like probably the feed fetching is network bound. So you might want to move that somewhere else. And yeah, with MessageFlow, if I wanted to make this a microservice, I would just remove the box from here and export this port. Oops, hard to click on this zoom level, and export that port. And now I can use a second tool to make those talk to a service running elsewhere over message queues. So
doesn't that make it more complex though? Because how do you retain the benefits of this visual representation if you don't?
Because then we zoom out one level more. Right now we are kind of zoomed into one application, and there we see, okay, that's where we go out from this graph, and this is where we come back in. But then you have a second graph that has the other side of this. And in FlowHub, you can actually, let's see, these things don't have subgraphs, but I think something else does. That one does. So here you can actually zoom into a graph also. So you can just see, okay, that's what's inside. So that answer your question?
I have one more question.
Yes.
Yeah, as you're talking to microservices, like if someone wants to use Restify or Koa, not Express, something like lighter version for microservices, so then what they should do? Like they don't want to use Express. Do you have any Koa or Restify components for this?
I don't know. I would have to go to NPM and see. If we don't, then writing a component. So
yeah. So I mean, the open source people will write for their own and upload to GitHub for others.
Yeah, that's usually what happens. But like our Express integration is seriously like maybe 100 lines of code. So
yeah, they can get the idea from there and write own or Restify stuff. Yeah.
Exactly.
Yeah. Can you please share your stuff? I will maybe make some for Koa or.
Go there and check it out. There's a lot of documentation. Yeah. Sorry. Yeah. You can ask also later.
Is Flow written in Flow?
Is Flow written in Flow? Yes and no is the answer. NoFlo itself is not written in NoFlo because we don't generate code, we don't have a compiler. So, I mean, there's basically no way we could be self-hosted. Like, we would have to generate code to do that. However, the whole IDE is written in NoFlo, so in that sense.
So, basically, NoFlo is just a config file.
Sorry?
NoFlo is just config file. JSON is just config file that wires one component or not.
The graph is so the question was NoFlo is just a config file. The graph, so one of these things here is just a JSON file, a config file saying, okay, that thing should talk to that thing, and then NoFlo is a library that makes it happen.
It makes it happen by binding this stuff when it bootstrap and it collects all those resources and create pieces of all those resources and then start writing them.
Yes.
Always does provide that all the time when it goes to that specific component of I need that component, so I will call this that lazy vector that will get pieces for that and just do that.
Yeah, so the question was, so NoFlo, whether NoFlo like loads all the components and all that stuff. Yes, that is correct. We do. There's also a way to inject code directly, so then NoFlo doesn't load them. You already loaded them, but the only place where we actually do that is usually on browser side, where kind of you want to do a single bundle anyway.
The question is about the export and exporting code. Instead of exporting code, can I create a component that connects with my microservice and just instead of using the message flow to still use the flow ID that you showed, but instead of exporting just using a component that connects with my microservice in IRPC way and returns?
Yeah. So the question was, when you create subgraphs, etc., can you make those be microservices? Sure. So like, there's nothing preventing you from writing a component that talks to your own API, just like we talked to my blog there with the RSS reader, right? So yeah, that's another way to do it. Of course, is if you have like REST-based or some other similar thing with microservices, then it's probably easier to just write a component that abstracts your microservice as a box here.
Do you also connect the front-end back-end stuff in the same graph, or is that?
Whether we connect front-end and back-end stuff. Yeah, in the same graph. Theoretically, you could. In practice, we've never really had the scenario. I think the only place where I've seen somebody do that, it's technically possible. I think the only place where I've seen somebody do that was for a arts project, where they wanted to do like visualization and some physical components to the same art piece that they were building in NoFlo for some exhibition. So I think they're there.
Okay, so when does it get slow? When you have tons of components?
Yeah. So when does it get slow? When does it stop scaling? Good question. I mean, NoFlo itself, like, there is a certain amount of overhead at startup, mostly because we need to find the components that are available, etc. But after that, when you start NoFlo, there's like, unless you put on all the debugging flags where, of course, there's more overhead. Like if you're tracing all the packets and keeping them in memory and all that, then there's going to be overhead. But if you don't enable them, then there is no particular overhead. Like there's a couple extra function calls. So like, I would say in general, the scalability limits of NoFlo are pretty much the same as normal Node.js itself. Yeah.
Okay, how easy or how complex is it to create a new component for NoFlo?
Well, the question was how easy it is to write a new component. So the answer is something that I'm probably disqualified to answer because I've done it a few times in my life. But there's documentation. The API is reasonably small. Yes.
How would I like review pull requests, see a diff, like resolve merge conflicts, stuff like that?
Oh, now we get to the nice stuff. Yeah. So yeah. So the question was what about reviewing pull requests and handling merge conflicts and all that stuff. And the answer is that's kind of where the visual metaphor, or at least the visual tooling we have right now, kind of breaks down. Like, you could probably do cool things like an animated GIF between two graph versions or something. But right now what we do there is, if you remember from early in the talk, I showed the textual graph language. There. And we actually have a tool that can make nicer GIFs with this. So for instance, you can actually, I don't think we have released it publicly yet, but we have a little bot that can go to your GitHub pull requests and make nice diffs there and stuff. So that helps quite a bit when you have be doing flow-based programming. But yeah, definitely an area where it would be fun to explore more better tooling, but we are not there yet. Okay. Yes.
How would they actually debug complicated program in NoFlo?
How do you debug a complicated program done in NoFlo? Well, I mean, how do you debug software in general? So first of all, you can use all the same tools that you have in Node.js because it runs on Node.js. So you can connect the Chrome debugger, and you can, of course, do the classic console log that we all love. That's all possible. But on the second level, yeah, first of all, you can see all the, like if you connect it to the IDE, you can see all the packets flowing through there. And then we have a tool called flow trace that you can turn on to capture lots of these things. And then you can replay those in the IDE. So that you can actually run on the server as well, like even in the live system. And you can set up certain conditions like, okay, if something hits this port here, which is, nothing should hit that because that's bad, then dump a trace. And then you can actually go here and you can replay it like it was happening then. So we have some nice tooling for that. But
so you were talking about the replay. Can you, for example, replay user interaction in your app or something? If you save like this flow stuff.
Yeah, so if you can replay user interaction, well, depends. Like if all of the user interaction happens within no flow space, then yes, the flow trace would probably contain all of it, and then you could maybe use that to recreate it. It really depends how your software is done. Okay.
I noticed that two of the components reference db.json. Now, if let's say you had a typo or somebody else didn't notice that was the same file, so some way to centralize that's my database and have them connect to that, as opposed to manually typing that in.
Oh man, you guys really catch me all the time. Yeah. So the question was, why was I doing these db.json things? And yes, I know this is ugly, this is wrong, but I just updated some components just before this talk, and I found out that there was a scoping bug. And yeah, this is a workaround. So normally in real world, what you would do is you would have one place where the database connection is defined, and you would send it to everybody who needs it. And that's how this graph would have looked like yesterday. But so just to explain why that happens. So the thing is, again, you might have multiple requests flying through, And if we go to the previous version of that graph, where we had the fetch feed there, how do you know that when you're responding to a request, the feed result here is for that request, right? Because, and for that, NoFlo has a concept of scope. So you can kind of create sub-flows where one flow doesn't see contents from the other flows. And that's what the resource router here does. So each request that you get in is sent as its own flow. And then basically, even though it's going through the same pipes, these components will only see data from one request at the same time.
Is that the different colors?
Huh?
Is that the different colors?
No, the different colors are just semantics. I like commenting my code. But yeah.
You did a server. Can you show us how to make a load balancer? Just double it and put a load balancer before, and should be easy. I think.
So is there NoFlo Nginx? That's the question.
The question was whether to do load balancer in NoFlo. Yes, you could do a load balancer in NoFlo, but I think that's a good idea. There's really good load balancers out there, and just go with HHroxy or Nginx and be happy with it. Or use one of the fancy ones from Amazon, or if you like Mockin. But yeah, I mean, theoretically you could. In practice, you probably shouldn't. Louder? Yep.
How do you independently scale a component?
How do you independently scale a component? You don't. So in NoFlo, this is all running in a single Node.js process. The way you independently scale a component is you go and split it out. So like if we said, fetch feed is becoming a bottleneck here, then you go to this variant here, where you actually send them to a queue, and then you have a worker that you can scale. And that's something we do quite a bit with Node.js. And the nice thing is, like, you can start with the monolith, you can actually identify the bottlenecks and then easily forward. Like, how long did it take me to extract that piece of functionality there? Yeah, then I would have to write one config file, but it's not too bad. Did that answer your question? Yes. Yeah, perfect.
Is there production-ready box that they are using NoFlo right now?
Yes, so the question was, is somebody actually doing this crazy stuff in production? And to paraphrase, yes, there are. Both actually like more traditional businessy web applications, and then like more from the artsy creative side of things. What I could mention is The Grid, which is a US startup doing AI web design. They're doing a lot of their backend in NoFlo.
And presumably the NoFlo site itself.
NoFlo site itself? No, that's just static HTML. We don't do that in NoFlo. Yeah. Okay. I don't know. Is it beer book? Or it's maybe one more question. Last question. Didn't count.
I heard that there are ports or something like that to another languages like Python.
Mm-hmm.
How this IDE works? There are defined lists of components for each language, or?
Yeah, so basically the question was, how does this work when you're talking to another language? And the way it works is when we connect to the runtime, we tell to the runtime, like, hey, please, could you tell me what components you have? And it gives the list. So like our IDE, before I started this demo, our IDE didn't know this list. It didn't have these components. It talked to the Node.js process I started, and then Node.js process said, okay, these are the NPM things I have installed. And Python would do exactly the same. Okay, I think that was it.